So today's class we'll see about differential equations. So this is just you have to understand the concept and solve problems. Okay. I have posted textbook PDF also. You can just check out that whenever you are free. So we are studying about solution to differential equations. Okay. So LTI system is always described by linear constant coefficient differential equations. Okay, or difference equations. So consider an LTI system described by nth order constant coefficient differential equations with a single input. Okay. Consider LTI system described by nth order constant coefficient differential equations. Okay. With single input x of t. So how will that equation look? Nth order constant coefficient differential equation with single input x of t, it will look like this: a naught into d to the power of n into y of t by dt to the power of n plus a1 into d to the power of n minus 1 into y of t by dt to the power of n minus 1, plus it goes on up to an into y of t, which is equal to x of t. So this is how you describe LTI system with respect to the nth order constant coefficient differential equation. Okay, with a single input x of t. So if I take in place of d to the power of n by dt to the power of n as s of n, let s of n is equal to d to the power of n by dt to the power of n. So what happens to this unit equation 1? This is our equation 1. So we are trying to describe LTI system by nth order constant coefficient differential equation with single input x of t. Suppose I will take this d power n by dt to the power of n as s to the power of n. How will this equation get modified? So equation 1 will become a naught into s to the power of n plus a1 into s to the power of n minus 1 plus up to an into y of t, which is equal to x of t. Correct? Followed? This is nth order constant coefficient differential equation with single input. I am substituting d power n by dt to the power of n as s of n, so you get this equation. Got it, everyone? Is it clear?
Yes, ma'am.
So the system which we are investigating is LTI system. LTI system means linear time invariant system, so that it will obey the principle of superposition as well as time invariancy. Okay, so the total response, because it obeys the law of superposition, the total response of the system is equal to the sum of natural response as well as forced response. Y of t is the total response of the system. Okay, it is equal to natural response plus forced response. So let us see what is this natural response and forced response. Given any differential equation, you have to find the total response of the system in this differential equations. Okay, they have to find y of t, which is a summation of natural response as well as forced response. There are some procedures to calculate natural response and forced response. Let us see that procedure. Okay, what is yn of t is natural response. So this natural response and forced response will have to obey the principle of superposition, so that it will be for a linear time invariant system. So let us see what is natural response first. Okay. Usually they'll give you a differential equation and they'll tell you to find a total response of the system. So you have to find the natural response and forced response using this procedure. We'll see that. So natural response is yn of t. It is represented as yn of t. So it is basically, it depends on the system details, okay, and it is independent of the nature of the input. Okay, this natural response, the structure of natural response, depends on the system details, and it is independent of the nature of the input. That is x of t. It is independent of x of t, but it depends on the system details. Okay, so it is also called as zero input response. Natural response is also called as zero input response. Okay, as the response of the system, it is the response of the system when the input is reduced to zero. We substitute, while calculating natural response, we take x of t is equal to 0. Okay, so it is called as zero input response. So it is called zero input response as the response of the system. It is the response of the system when the input is reduced to 0. So it is called as zero input response. So it is the response of the natural response is basically the response of the system produced by initial conditions only. You will be given some initial conditions. So this is a response. Natural response is a response of the system which is produced by initial conditions only. Okay. So now we have seen what is this equation. A naught into s power n plus a1 into s power n minus 1 plus up to a power n into y of t, which is equal to x of t. So the characteristic equation is this one. So the roots of the characteristic equation will determine the time domain, the expression for zero input response. So the characteristic equation is a naught into s to the power of n plus a1 into s power n minus 1 plus so on up to an, which is equal to 0. So this roots of this characteristic equation will determine the time domain expression for the zero input response. Okay, so let us see how do we represent the natural response. So yn of t is equal to k1 into e to the power of s1 of t plus k2 into e power s2 of t, so on up to kn into e power sn of t. Okay, this is the natural response will be in this form. So s1, this s1, s2, s3 are all the roots of the up to sn are the roots of the characteristic equation. Okay, so k1, k2, k3 up to kn, these are all constants. Okay, these are constants with respect to this equation, and they are determined making use of the initial conditions. So S1, S2, S3 are the roots of characteristic equation. If you solve the characteristic equation, you'll get S1, S2, S3 and all. K1, K2, K3 and all you have to determine by making use of the initial conditions, which will be given in the question. Okay. So that is about this. So we have some summary chart for roots of the characteristic equation and form of the natural response. Depending upon the roots of the characteristic equation, the form of the natural response will be accordingly. Okay, so let us check that. So you have a table that summarizes the form of natural response for different root conditions. So table for the form of natural response for different root conditions of the characteristic equation. So you have roots of the characteristic equation table and you have the form of natural response one side. So if your roots of characteristic equation are real and distinct, that is in the form of R, then the form of natural response will be of the form k into e power RT. Okay. So if the roots of the characteristic equation which you solve it are complex conjugate, like a plus or minus j omega, the form of natural response will be e power at into k1 cos omega t plus k2 sin omega t. Okay. Third one is, if the roots of the characteristic equation are real and repeated, if you get the same characteristic equation, like if you get S1 and S2 both same, it is of the form r to the power of p plus 1, which is equal to e power RT into k0 plus k1 into t plus k2 into t square, so on up to kp into t power p. Okay, this you have to remember. This block you have to remember. If the roots of the characteristic equation are real and distinct, then the form of natural response will be k into e power RT. What is this R? That are roots of your equation, characteristic equation. If it's R, if it's real and distinct, so you'll have k into e power RT. If it's complex and conjugate, that is of the form a plus or minus j omega, so your natural response will be e power at into k1 cos omega t plus k2 sin omega t. Okay, if your roots of characteristic equation are real and repeated r to the power of p plus 1, so it will be e power RT into k0 plus k1 into t plus k2 into t square up to kp into t power p, depending on this p. If there are two roots, then you will have k0 plus k1t, e power RT into k0 plus k1t, like that. Okay, if they are same, real and repeated. So once we solve problems, it will be clear. This is about natural response. Now let us see about the forced response. Forced response is represented as yf of t, right? So total response is the summation of natural response plus forced response. So this forced response is also called as zero state response. Okay, it is also called as zero state response, and it is a response of the system when produced by input only. It is a response which is produced by the input of the system only. So the structure of forced response will be yf of t will be yn of t plus yp of t. So this forced response is a summation of natural response plus particular response. Okay. So the constants produced present in this forced response are evaluated by assuming zero initial conditions. So particular response has the same structure as the input, and it will satisfy the given differential equation. So if x of t is equal to u of t, then the particular response yp of t will be equal to c, because u of t is a constant which is 1 from 0 up to infinity. The particular response will be c. Okay, so you have one more chart for this, inputs as well as particular response. Depending on that, we shall see how the particular response will be depending on the inputs. So you have input side and you have structure of particular response. So if the input is a constant, if it is some constant C0, then output structure of particular response will also be some constant C1, which is another constant. As we have seen, if u of t is your x of t, particular response will be some constant, because u of t is also constant, it is 1, right? Next, you have e power alpha t. If your input is of the form e power alpha t, then the structure of particular response will be c into e power alpha t, constant multiplied by e power alpha t. Next, if your input is of the form cos omega t plus beta, if the input is of this form, then structure of the particular response will be C1 cos omega t plus C2 sin omega t. Okay, these things are there in textbook. I'll also give you notes for this. So just try to understand these topics. Next, you have e power alpha t into cos omega t plus beta. If your input is of this form, then the particular response will be e power alpha t into C1 cos omega t plus C2 sin omega t. You have to remember all these things. Okay, this particular tabular column for natural response, structure of natural response and structure of particular response you have to remember. And if your input is of the form t, then structure of particular response will be C0 plus C1 into t. Then if it is of the form t power p, then it will be C0 plus C1 into t plus C2 into t square up to Cp into t power p. Then if your input is of the form t into e power alpha t, then it will be e power alpha t into C0 plus C1 into t. Okay. So this is the table for input and structure of particular response. Okay. So there is one condition: if your input x of t is equal to e power alpha t, where alpha is also a root of the characteristic equation. So if this is also a root of characteristic equation repeated m times, then the structure of particular response will be multiplied by t power m. Okay. So this will be multiplied with t power m. So this is a note. We shall see different types of problems. So this is about the natural response and particular response. Forced response is a summation of natural response plus particular response. So this is natural response. First, given a problem, you have to find the roots of the characteristic equation. Then you have to find K1, K2 and all. So the natural response will be depending upon the roots of characteristic equation. Okay. Next, you go on to find the forced response. Forced response is zero state response. It will depend on the input only. So it will be yn of t plus yp of t, forced response. Natural response plus particular response. So particular response, if your input is of this form, its structure of particular response will be of this form. Did you follow? Try to understand this. When we solve problems, it will be clear. So shall we solve one problem on this?
Ma'am, C1 of t is constant or that like function, ma'am? C1 into t, ma'am?
C1 into t.
Okay, ma'am.
Okay, C1 into t. This is also C1 into t. C2 into t square. This is C0 plus C1 into t, like that. If it is t, you'll get C0 plus C1 into t. If it t square means C0 plus C1 into t plus C2 into t square, like that. Okay, depending on this p. This is t to the power of 1. So it is C0 plus C1 into t. Not C1 of t, not a function of C1. So it is C1 into t. Okay, just C1 into t. This is also C1 into t. So let us take down our problem and try to solve that. You will get some idea. So take down, evaluate natural, forced and total response of the system given below. Okay, so the system which is given is y dash of t is plus y dash of t plus 5 times y of t is equal to u of t. So they are giving you initial conditions. Y of 0 is equal to 2. This is the given question. So you have to find the natural response, forced response, and total response. Total response is an addition of natural response and forced response. Natural response will depend upon the roots of the characteristic equation. Then forced response is natural response plus particular response. Particular response will depend on the input. Depending on the input, you will get different particular responses. And at the last, to get a total response, add these two. Is it clear? Shall we start solving? Clear, everyone? Is the question clear?
Yes, ma'am.
You have to evaluate natural response, forced response, and total response of the given system. So this is the characteristic equation. So what is the characteristic equation? Can I write it as S plus 5 is equal to 0? Shall we take like this? S plus 5 is equal to 0. This is first order. So y dash of t plus 5 y of t is equal to u of t. So the characteristic equation is S plus 5 is equal to 0. So S is equal to minus 5 you get. Okay. So what form of characteristic equation is this? We have seen here, right? If your characteristic equation is real and distinct, what type of, you have got S is equal to minus 5. What type of, in these three, which type is that? It is real and distinct, right? So it is of the form R. So natural response will be of the form K into e power RT. Okay. So S is equal to minus 5. So the natural response is given by K1 into e power RT, because it is real and distinct, right? Minus 5 is real and distinct. So it will be K1 into e power minus 5t, natural response. Okay. So now we have to find this K1. Okay. Let us try to evaluate this K1. So this constant K1 is found by making use of the initial conditions given. So in the problem, they have given you initial condition y naught is equal to 2. Okay, this is the initial condition which is given. So y naught, y of 0 is equal to 2. This is y of 0. Okay, y of 0 is equal to 2. So making use of this, we'll find out what is K1. Okay, so 2 is equal to K1 into e power minus 5t. So at t is equal to 0, because this is y of 0. Okay. So what is K1?
2.
K1 is equal to 2. So we can say that natural response of the system yn of t is equal to 2 into e power minus 5t. This is the natural response of the system. Now let us find the particular response. Okay. So that we can get the total response of the system, y of t, which is nothing but natural response plus forced response. So forced response is the summation of natural response plus particular response. So did you till here it's clear, everyone?
Ma'am, they have given y of 0, ma'am, but you have taken yn of 0, no, ma'am.
No, y of 0 is equal to 2. This is y. Yes, this is yn of t. It is of this form, k1 into e power minus 5t. In place of t, if you put 0, you get y of 0, right? It is equal to 2. They are giving you initial conditions. So we'll find natural response, that is constants k1 using the initial conditions only. So 2 is equal to k1 into e power minus 5t at t is equal to 0. If you substitute t is equal to 0 in this will be 1. So you get k1 is equal to 2. Got it?
Yes, ma'am. Y of 0 and yn of 0 are same, ma'am.
Yeah, we are substituting t is equal to 0. That's all. Initial conditions is y of 0 is equal to 2. This is yn of t. To get the constant k, to find out the constant k1, we are equating this initial conditions to our natural response, which is of this form. So that we'll get the constant k1. Got it?
Yes, ma'am.
So we'll see about the particular response. So as you can see, the input is given to be u of t. Means x of t is equal to 1. Unit step amplitude is 1, right? So this is x of t, right? So x of t is the input. So for particular solution, it will depend on the input, right? So x of t is equal to 1 for t greater than 0. That is your u of t. So this particular solution yp of t will be of the form c. Okay, because it's a constant. Your particular solution will also be some other constant c. Got it? So how do we find this some constant, another constant c? So we have to find the constant c by substituting the particular solution in the given differential equation. So yp dash of t plus 5 times yp of t is equal to 1. So this is our characteristic equation, right? We are substituting particular solution yp of t in the differential equation which we have been given in the question. So it is y dash of t plus 5y of t is equal to u of t. So yp dash of t plus 5 yp of t is equal to 1. So y particular solution will be of the some constant c. So what is first differential of this constant? If you differentiate a constant, what do you get? We get 0, right? 0 plus phi c. 0 plus phi c is equal to 1. So c is equal to 1 by 5. Got it? Because if you differentiate d by dt of yp of t, you get 0. So I substituted that 0 here. So 5c is equal to 1. C is equal to 1 by 5. Got it, everyone? Is it clear? Is it clear or not? So if our input is some constant, output structure of particular response will be some another constant. So our input is unit step. It is 140 greater than 0. So particular solution will be some constant c. We don't know what is that c. So we have substituted that as c. And we are evaluating that c by using the differential equation. Yp dash of t plus 5 yp of t is equal to 1. Because this is of some constant, particular solution also will be some constant c. So yp of t is a constant. So I have taken that in the form of differential equation. Yp dash of t plus 5 times yp of t is equal to 1. So if first differential of that is 0, 0 plus 5c is equal to 1. So c is equal to 1 by 5. Got it, everyone? The particular solution is yp of t, which is equal to 1 by 5. Got it, everyone? Clear? So we have solved natural response and particular response. Now we shall see forced response. The forced response of the system is given as yf of t. It is a summation of yn of t plus yp of t, right? Forced response, so total response is natural response plus forced response. Forced response is natural response plus particular response. Okay, so yf of t forced response is equal to natural response plus particular response. So what is natural response which we got? K1 into e power minus 5t plus 1 by 5. Okay, here you have to take K1 only because we are finding the forced response. Now we are evaluating this K1 again. We have to find this K1 again by assuming 0 initial conditions. Okay, so that will be yf of 0 is equal to K1 into e power minus 5 into 0 plus 1 by 5. So if we put t is equal to 0 in this equation, we'll get yf of 0. So you get K1 plus 1 by 5 is equal to 0. So K1 is equal to minus 1 by 5. So the forced response will be yf of t, which is equal to minus 1 by 5 into e power minus 5t plus 1 by 5. Got it? Is it clear? Clear, everyone? So if you practice few problems, it will be clear. So this is how we find the forced response. Again, you take the form of natural response in the form of K1, K2, however it is, and add with particular response. Then using the zero initial conditions, assuming zero initial conditions, again find the K1. This is the forced response. Got it? Which is natural response plus particular response. Now you can find the total response of the system. The total response of the system is y of t, which is equal to yn of t plus yf of t. So yn of t is, what is yn of t? Yn of t was 2 into e power minus 5t. It's 2 into e power minus 5t, and yf of t is minus you have. So it is minus 1 by 5 into e power minus 5t plus 1 by 5. Okay, so we can solve these two, right? Because both are of the form e power minus 5t. So 2 minus, what is 1 by 5? It's 0.2. 2 into e power minus 5t minus 0.2 into e power minus 5t plus 1 by 5. So if you solve this, you get 1 by 8 into e power 1.8 into e power minus 5t plus 1 by 5. That is 0.21 by 5. You can keep it like this. This is your response of the system, total response of the system, y of t. Got it, everyone? 1.8 into e power minus 5t plus 0.2 for t greater than or equal to 0, because your input is unit step signal, or you can also write 1.8 into e power minus 5t plus 0.2 into u of t. This is your output y of t. Got it, everyone? Is it clear?
Ma'am, show that forced response calculation, ma'am.
Yeah. So forced response is natural response plus particular response. When you're calculating the forced response, don't substitute this forced response what you have got it there. Put it in the form k1 into e power minus 5t. k1 into e power minus 5t, put this structure of that for natural response. Okay, k1 into e power minus 5t plus particular response is 1 by 5. Now assuming the zero initial conditions, you find out what is k1 again. So yf of t will be natural response plus particular response. So k you will get 1 minus 1 by 5. So substitute that in place of this k1. Yeah, k1 you will get minus 1.5. That you have to substitute it here. So this forced response plus natural response is total response of the system. We shall see few more problems. You will understand how to do this forced response by assuming zero initial conditions. Shall we take one more problem? Clear, everyone? These problems, if you practice, it will be easy. Okay, it might seem like somewhat if you do it for the first time. If you practice it, it will be easy. So take down one more problem.
Excuse me, ma'am.
Yes.
Ma'am, why did you write u of t at the last, ma'am?
Because our input is u of t, no? It is existing, it is equal to u of t. Because that x of t is given to be u of t, that means it will start from t is equal to 0. Got it?
Okay, ma'am.
So take down this problem. Evaluate the total response of the LTI system. Described by the differential equation. Which is given as y double dash of t plus 5y dash of t plus 6y of t is equal to 2 into e power minus t into u of t. So initial conditions which are given as y of 0 is equal to 0 and y dash of 0 is equal to 1. This is the given initial condition and this is the given differential equation. You have to find the total response of the LTI system. What is total response? It is natural response plus forced response. So let us find the roots of the characteristic equation. So we have s square plus 5s plus 6 is equal to 0. What are the roots of this characteristic equation? 3, 2. 3 to the 6, 3 plus 2 will get 5. Okay, so you'll get s is equal to minus 2 and s is equal to minus 3. You know how to solve this? So you have s square plus 3s plus 2s plus 6 is equal to 0. So if I take s common, I'll get s plus 3. Similarly, if I take 2 common, I'll get s plus 3, which is equal to 0. So I'll get s plus 2 is equal to 0 and s plus 3 is equal to 0, where you have s is equal to minus 2 and s is equal to minus 3. Got it? So the roots of this characteristic equation are minus 3 and minus 2. Did you get this? It's clear or not?
Yes, ma'am.
Now you take what is the natural response of the system. Yn of t is, so these are real and distinct. So you'll have k1 into e power minus 3t plus k2 into e power minus 2t. So this is the natural response of the system. Now you have to find the constants k1 and k2 by making use of the initial conditions. Okay. So yn of t is given to be k1 into e power minus 3t plus k2 into e power minus 2t. So first initial conditions is y of 0 is equal to 0. So if you substitute n t is equal to 0 in this equation, what will you get? Y of 0 is equal to k1 into 1 plus k2 into 1, which is equal to 0. Yes or no? In this equation, substitute t is equal to 0 first. Okay, first initial condition is y of 0 is equal to 0. So that is equal to 0. If you substitute t is equal to 0, you will get 0 here. So I put that k1 into e power minus 3 into 0 plus k2 into e power minus 2 into 0. So this will be 1. So k1 plus k2 is equal to 0. So k1 is equal to minus k2. Take this as equation 1. So now next to what they have given you another initial condition. Y dash of 0 is equal to 1. So now make use of the next initial condition. Y dash of 0 is equal to 1. So now you differentiate that equation, this equation yn of t, and submit and equate that to 1. Okay. So d by dt of yn of t is equal to d by dt of k1 into e power minus 3t plus d by dt of k2 into e power minus 2t. You take. Now that is equal to 1, right? So substitute this thing equal to 1. So 1 is equal to, if you differentiate k1 into e power minus 3t, what will you get? Differentiating this, what do you get?
Minus 3k1 into e power minus 3t.
Yes, k1 into minus 3 into e power minus 3t plus k2 into minus 2 into e power minus 2t. This is the equation which you have got. Now put t is equal to 0 in this equation because y dash of 0, right? So put t is equal to 0 in this equation. If you put t is equal to 0, what will you get? 1 is equal to k1 into minus 3 plus k2 into minus 2. So you will get one more equation, minus 3k1 minus 2k2 is equal to 1. This is your equation 2. Now solve equation 1 and 2 and tell me what is k1, k2. Equation 1 is k1 is equal to k minus k2 and equation 2 you have got minus 3k1 minus 2k2 is equal to 1. So solve these two, what will you get? Or in place of k1 put minus k2 here and tell me what is k1 and k2.
And K2 is plus 1, K1 is minus 1. ma'am.
K1 is minus 1, K2 is 1. Did everyone get this?
Yes.
Followed? Okay. So now your natural response yn of t will be equal to minus 1, that is k1 into e power minus 3t plus k2, that is 1 into e power minus 2t. Got it? For t greater than or equal to 0. Clear? This is your natural response. So now input, what is the input? Now you have to calculate a particular solution, particular response, right? What is the input in the given question? The input is 2 into e power minus t into u of t. Okay. So what is the input? X of t is given to be, now we are calculating the particular response. Okay, x of t is 2 into e power minus t. This you keep it somewhere. We can use it for total response later. So x of t is 2 into e power minus t into u of t. And the roots of the characteristic equation are minus 2 and minus 3. So a particular solution will be of what type? Yp of t, the solution will be of, structure of that particular solution will be of what type? Which form is this? So the input is of the form c into e power alpha t. So that particular solution will be of the form, okay, input is e power alpha t. So input is of the form e power alpha t. So particular solution will be of the form c into e power alpha t. Okay, let us see the table once. So if it is of the form e power alpha t, then your structure of particular response will be c into e power alpha t. Got it? So I have substituted c into e power alpha t for particular solution. Let us calculate that. So input is e power alpha t, particular solution is c into e power alpha t. So how do you find out the constant c? C into e power alpha t. You have to find out c, constant c. So the constant c is evaluated by substituting the particular solution in the given differential equation. Okay, so you get yp double dash of t. It is of the form c into e power alpha t. You have to find c now, this constant c. So I'll take this particular solution in the form of the differential equation. Yp double dash of t plus 5 times yp dash of t plus 6 yp of t is equal to 2 into e power minus t. U of t is 1. Okay. So yp of t is c into e power minus t. C into e power minus t. So you have to find what is c. So
Ma'am, scroll down, ma'am.
yes.
Yes, ma'am.
Okay. So now what you have to do is yp of t is equal to c into e power minus t. It is of this form. So yp dash of t will be, what is yp dash of t? You understood how we got this? So you have 2 into e power minus t into u of t. So that is some constant into e power minus t. We have got this particular solution from the input only. Okay. So we have c into e power minus t. That is the particular solution. So now what you have to do is you have to take the differential of that. So yp dash of t will be equal to c into minus 1 into e power minus t, which is equal to minus c into e power minus t. Then take yp double dash of t and substitute these here. Okay. So yp double dash of t means differentiate this one. So you have minus c into minus 1 into e power minus t, which is equal to c into e power minus t. Substitute this c into e power minus t, minus c into e power minus t, and c into e power minus t in this equation to find out that c. So you have c yp double dash of t c into e power minus t plus 5 times c 5 times minus c into e power minus t plus you have 6 times c into e power minus t, which is equal to 2 into e power minus t. Okay. So solve this equation. You get c into e power minus t minus 5c into e power minus t plus 6c into e power minus t, which is equal to 2 times e power minus t. Okay. So if you take e power minus t common, you have 1 minus 5c plus 6c into e power minus t is equal to 2 into e power minus t. So 2c equal to 2. So c is equal to 1. Got it? Is it clear?
C minus 5C, right, ma'am?
Yeah, 1c. Got it? So a particular solution yp of t is c into e power minus t. So 1 into e power minus t, it is of the form e power minus t. It is of e power minus t. Got it? This is the particular response. This is how we are finding the particular response. Understood? Is it clear? Clear, everyone?
Yes, ma'am.
X of t is 2 times e power minus t into u of t. U of t is a constant which starts from 0 and it will go up to infinity. Take that as 1. So yp of t is of the form c into e power alpha t. Okay, so we'll take alpha as minus 1 here. So you have 2 into e power minus t. So yp of t is c into e power minus t. So you take down that particular equation in the form of differential equation. Okay, if you will get like this. This is given in the question only. Okay, so now you find first differential, second differential, you will get the according answers that you put in this equation and try to find the value of this c constant. So it is given to be 1. So particular solution is yp of t is 1 into e power minus t. So e power minus t. Now you have to find the forced response of the system. Forced response is the summation of natural response plus particular response. So yn of t plus yp of t. Okay, so yn of t is k1 into e power minus 3t plus k2 into e power minus 2t plus e power minus t. Now again you have to find k1 and k2 assuming the 0 initial conditions. Okay. So yf of 0 is equal to k1 plus k2 plus 1 is equal to 0. Take this as equation 3. Next you take y f dash of 0. So that will be y f dash of t you will take, then you take t is equal to 0. So if you differentiate this equation y f of t, so you will get k1 into e power minus 3t into minus 3 plus k2 into e power minus 2t into minus 2 plus minus 1 into e power minus t. So you will get minus 3 k1 into e power minus 3t minus 2 k2 into e power minus 2t minus e power minus t. Okay, so now substitute t is equal to 0. Y f dash of 0 will be minus 3 k1 minus 2 k2 minus 1 is equal to 0. This is your equation 4. Solve equation 3 and 4 and tell me what is k1, k2. Equation 3 and equation 4 you solve it and tell me the values of k1 and k2. We'll get the forced response equation yf of t. What is k1, k2? Solve these two, this one and this one. Solve and tell me k1 and k2 what you
1
get.
and minus 2, ma'am.
K is 1, k2 is minus 2. So yf of t is nothing but k1 is, put it in this yf of t, 1 this equation. Okay, so k1 is 1, so 1 into e power minus 3t minus 2 into e power minus 2t plus e power minus t. This is your forced response of the system for t greater than or equal to 0. Okay, total response is, now total response will be natural response plus forced response. Add that natural response and forced response. Okay, so natural response, so forced response is this one. Natural response, what is that? Can anyone tell the natural response? What we got previously? It is minus 1 into e power minus 3t plus 1 into e power minus 2t. Minus 1 into e power minus 3t plus 1 into e power minus 2t. That is natural response. Plus forced response will be 1 into e power minus 3t minus 2 into e power minus 2t plus e power minus t. So whichever you can solve, you solve it. This and this gets cancelled. So if you solve this and this, you get minus e power minus 2t plus e power minus t for t greater than or equal to 0. Right? Or you can write y of t is equal to minus e power minus 2t plus e power minus t for t greater into u of t. Got it, everyone? Is it clear?
Yes, ma'am.
Is it clarified?
Yes, ma'am.
Solving these equations, you have to do it. Okay. I hope it is clear now. You have got some idea how to solve this differential equations. So this is how you have to solve it. Okay. I'll brief up once, or I'll brief up in next class. If it's clear till here, then we can wind up this session. It's already 3 minutes late. You can write your name and USN in the chat box. If you have any doubts, you can get it clarified.
Ma'am, tomorrow what is the portions, ma'am?
Tomorrow, you have quiz, right? So, except this differential and difference you take, unit 2 and unit 3. Is it fine?
Ma'am, can you reduce it, ma'am?
Okay, so unit 3 you take, unit 3 full along with interconnection.
Okay, ma'am.
Ma'am, is it MCQs or solving, ma'am?
Solving, no MCQs.
Okay.
So portions is unit 3 and unit 2 interconnection.
Ma'am, unit 3 full, ma'am.
Yes, it's there.
And ma'am, unit 2 interconnections.
Interconnection. Interconnection of LTI systems, systems in cascade, systems in parallel. Such type of problems. If they're in parallel, h of t will be plus or minus, right? h1 of t plus or minus h2 of t. If they're in cascade or series, it will be h1 of t converted with h2 of t. Like such type of problems.
Okay, ma'am.
Ma'am, this
We'll
differential
continue.
equation.
Come again, Praveen.
Ma'am, differential equation, ma'am.
Differential is not there. I will continue this class in tomorrow's tutorials. Differential is not there.
Ma'am, is this third chapter or fourth chapter, ma'am?
Which one?
This differential equation, ma'am.
It is unit 2. It's a topic in unit 2. Difference equations, differential equations.
Okay.
I didn't do that time, now I'm doing that. Clear everyone? You have any doubts? Thank you, students.
Thank you, ma'am.